Hi everyone, let's solve this problem. Add two numbers. You are given two non-empty linked lists representing two non-negative integers. So they will all be positive integers. The digits are stored in reverse order and each of their nodes contains a single digit. So let's say for example, in this case, if the number is 342, they have given us 2, 4 and 3. So the numbers are in the reverse order, that's what they are telling. And also every node contains a single digit, so this is the actual number numerically, but since they are reversed, it starts with 2 4 3, and also every node has a single digit. That's what they are trying to say. So obviously the numbers will be from 0 to 9, they will not be more than that. If you see here, 0 to 9 will be the node values. Now let's try to understand it further. So even before we actually solve this problem, let's actually take a mathematical problem. Let's say 342 plus 465. So since the numbers are given in the reverse order, I have just calculated 342 for the first one and 465 for the second one. That's it, nothing major here. So how do we add it? So basically we add 7. That's nothing but we will start our calculations from the first node. So we know that that is a value of 7, right? And then 4 and 6, what is the total? 10. So we will have a carry and value at that particular position 0, right? 0. Now we have 3 plus 4 plus 1, we also have to add the carry, so it will be 807. So this is the answer. If you check this particular use case, it is 708. The only tricky part is that which you just have to understand is that the numbers are given in the reverse order. You don't have to worry much, you are just starting from the start of the list and you will be able to compute these values this way, because they have given it in the reverse order, because you can compute from the right to left. That is the expectation here. Now let's take even a better example than this. So let's say I have 2 4 3 5 6 8. Let's say this is the use case. Then since we are starting from the start, 2 plus 5 will be 7. Because this is a linked list traversal, I'm just doing it. And then I'm at 4 and 6, it will be 10. 0 will be here, 1 will be here, and 3 plus 8 is 11. 11 plus 1 is 12. We have to, and 1 will be carry forwarded, so 1 we will have to create a node, right? So now in this case there are 4 nodes instead of 3 nodes, because we might also happen that the last digits, some of the last digits might create a carry, and that also has to be put in the node value and return the head. So this is the expectation. So now let's also figure out one more use case. Let's say for example I just have 2 4 and 5 6 8 different number of digits. It would be 7, it would be 10, 1 will be carry forwarded, and it will be 9. I hope this is clear. I just wanted to show 3 different use cases here. One is the equal lengths and no carry, equal lengths and carry forward, and there is different lengths. That is all we are going to we are use cases which are we are going to encounter. And one more thing here is that carry forward case will be the same thing here. Let's say for example, if I just have different lengths, 5 6 9 instead of 8, it will be 7 this will be 10, that is 0 here, carry forward here, 10 again, 0 here, and carry forward will be 1. So this is how we create the linked list. It's a simple problem. So now let's try to understand the code. So we will create a dummy node for us to return the value, list value easily. So new list node of some value 0, it should not matter to us. Let current, this is for us to create our new linked list and track the nodes. So it will be pointing to dummy initially. So we have two lists, L1 or L2 or carry. So we also have to have a carry, right? So even in this case where we just had a carry value here, we had to create a new node. So we also have to ensure that we encounter the carry here. So carry initially will be 0, and now in this case we have to find the sum of the nodes, right? So if L1 dot value is present, we will consider that, or we will consider it as 0. This is because in this case the value is not present, but we will consider it as 0 for us to add 0 and 9 and 109 to get the value. So fine, and then it will be L2 dot value plus carry, if at all there is a carry. We are going to store these carry in the carry variable, so we will add this. Now once we get the carry, we have to ensure what will come in. Let's say we got so 4 plus 6 is 10, right? And there is something as carry and something as value which we need to insert, right? So when we get 10, the remainder value will be the value which we will create the node with, and this part will act as our carry. So how will we get this? We will get this by sum /10, and this will be sum by sum percentile 10. So now let's try to write it up. So in this case carry will be math.floor of sum by 10, and we have to create a new node, right? Current dot next will be new node, or for us to understand it easier, new node is equals to new list node of, as we discussed, it is sum percentile 10. Once we get this node, we will ensure that current dot next is pointing to new node, and once we get the new node, what will we do is we will also move our current to the next node. Now once we are done with these things, now we also have to move our L1 and L2s, because we have already processed L1 values and L2 values. L1 is equals to L1 dot next, L2 is equals to L2 dot next, right? We are having this if conditions because we are, if there is one of the list is lesser of size, let's say list 1 is of length 2 and list 2 is of length 3, L1 might not be available in that case, right? So we have to add those checks, and at the end we have to return dummy dot next, because the actual nodes which we have created are starting after this dummy node, so it will be dummy dot next. Now let's try to run this and let's submit it. Now let's also understand the time complexity of this. Time complexity of this solution is nothing but big O of n plus m, considering that there are n nodes in list 1, m nodes in list 2, it will be big O of n plus m. And the space complexity of this solution would be big O of max of n comma m, right? Because at max you can have a one more additional node, you cannot have more than that, one node, right? So in that case it would be just max of n comma m.